Hi students, let us continue with the chapter 8, HCF and LCM. We had already done few questions from exercise 8b. Now let me start with the next topic, finding HCF using division method. HCF using division method. That is third main of exercise 8b. Okay. Let me start with the first question. Question number 1, 16 and 24. So how do we do? Use the division method. You can write 24 and 16 outside. So how many times will 16 go in 24? One time. So I can just write it like this. Okay, this can be written this side. 1 time 16, remaining is 8. Now as I explained in the previous class, 16 comes here. So 16, how many times? 2 times. 2 8s are 16, 0. So what is our HCF here? HCF will be equal to 8. Okay. Let me do the second question. Second question is 18 and 30. 18 and 30. So always remember, you need to write the larger number inside as the dividend and smaller number as the divisor. 18 goes 1 time. That is 18. Your remainder will be 12. So again 18 comes here. So how many times? 1 time, 12. 6. Next you need to transfer 12 here. 12. 6 2s are 12. 0. So what is our HCF here? HCF is equal to 6. Okay. Hope it's clear. Coming to the third question. Third question is, we have 3 numbers. So let's see how to do when we have 3 numbers. 7, 14 and 24. So let me start with the first 2 numbers. 7 and 14. Okay. 14 goes how many times in 7? 2 times. 2, 14, 0. So what is the number here? 7. So let me take that 7 here and I'll write 24. 7 goes in 24 how many times? 3 times. 3 7s are 21. 3 balance. Now I have to transfer this 7 here. So I get 7. How many times? 2 times. 6. Goes 1. So this should be brought here. So 3. In 3, 1 goes how many times? 3 times. 3 1s are 3, 0. So what is the HCF for all the 3 numbers? HCF is equal to 1. Okay. When I take for 7 and 14 alone, I got HCF as 7. But when I do for 7, 14 and 24, my HCF is 1. Because there is no common factor between 7, 14 and 24. Okay. Hope it's clear to you children. Now let me do the fourth sub-question. So let us do the next question. That's the fifth question. Fourth question. 70, 80, 120 and 150. So here we have 4 questions, 4 numbers. So how do we start? We'll start with the first 2 smallest numbers. So let it be 80 and 70. 1 time. So we can take it as 1 time. 70, 10. So I transfer 70 here. So I get 7 times 70. So here I'll get it as 10. So let me continue with that 10. 10, 120. It goes how many times? In 120 it will go 12 times. So 120. 0. So again with this 10 I'll do the next number. 150. 15 times 150. So how we did it? First you have taken 2 numbers and solved. Then with that HCF you will solve the next number. With that remaining HCF you will do the next one. So what is the final remainder? Final divisor will be your HCF. So HCF is equal to 10 here. Okay. So this is how you will do the division method. Now in the next main it's clearly given that use a method of your own choice to find the HCF of. That you can do it yourself. You can use any of the method and solve it. Okay. Now let me do the fifth question. Find the greatest number that divides each of the following 120, 225 and 315 completely. So here also you can use the you have to find the HCF. So HCF will be the greatest, highest common factor. It is the greatest number that divides all these numbers. So you can use any of the three methods, whichever is easy for you. So I will be using this method. 315 divided by 5. So what I get? 5 3 times 36 times. Again 4 5 6 3. Okay, 63. Now is there any common factor? Just check. We have 3. 3 it goes 12 times. 3 it goes 15. 3 it goes 21. Again I can divide with 3. 3 4s are, 3 5s are, and 3 7s are. Now further I cannot divide it. So what is my HCF here? 5 into 3 into 3. 5 3s are 15. 15 3s are 45. So here 45 is the greatest number that divides each of the following: 180, 225 and 350. So this is how we can find it out. Okay. Now coming to the sixth question. Show that 45 and 56 are coprimes. In order to show that 45 and 56 are coprimes, we need to divide them completely and we have to check whether there is any common factors. Let us check. 3. So it is 15. I'll do it separately and check. 3, 5, 5, 1. Similarly 56. I will start with 2. 28, 2, 14, 7, 2, 7, 7, 1. So here the factors are 2 and 7. Here the factors are 3, 3 and 5. Is there any common factor? No. So HCF is equal to 1. If there is no common factor between them, HCF will be equal to 1. So if the HCF of two numbers are 1, so you can tell them they are coprimes. Okay. So hence it is proved. So next, out of 15, 16, 21 and 28, find out which are the pairs of coprimes. So let me find them separately. 3, 5, 5, 1. 16, 2, 8, 2, 4, 2, 2, 2, 1. Okay. In coming to 21, 3, 7, 7, 1. 28, 2, 14, 2, 7, 7, 1. So which of these are coprime? I can tell that 15 and 28 are coprimes because there is no common factor between 15 and 28 other than 1. Similarly, I can tell that 16 and 21 are coprimes. Okay, but 15 and 21 I cannot tell. 3 is common in both. 16 and 28 also cannot tell. So the pairs of coprimes here are 15 and 28 and 16 and 21. Okay. Now coming to the next question, 8th one. Find the greatest number that will divide 93, 111 and 129, leaving 3 in as remainder in each case. So since 3 is the remainder, I will subtract 3 from all these 3 numbers. That is 93 minus 3 I will get 90. 111 minus 3 I will get 108. And 129 minus 3 I will get 126. Now in order to get the required number, I have to just find the HCF of all 3. Because they told that in each of the case you will get remainder as 3. Correct? So if remainder is 3, if you subtract 3 from each of this number, that will be a factor. Correct? So find the HCF. So what you get? 108 and 126. So let me do this method only. 2. 45. This will be 54 and this is 63. Again I can divide with 3. 15 and here 3 is 1, 18 and 21. Again I can divide with 3. 5, 6, 7. So what is the required number here? Greatest number that divides all the 3, leaving remainder 3. So it is 2 into 3 into 3. 2 3s are 6, 6 3s are 18. So that number is 18. Hope it's clear to you all. Okay. So students, complete exercise 8b in your classwork. Okay, I will start with multiples and LCM in the next class.